some of these things. You may have done it before. You may have, you may not. You may have know the solution, but don't quite understand why it works that way. So yeah, we're going to look through a couple of things and just work through it that way. Yeah, don't worry about me. I'm James. Well, if anyone wants to follow me on socials or whatever, LinkedIn is probably the best. I'm not on Twitter much anymore. I've given up on that. But that is technically my Twitter handle, and that's my LinkedIn handle. But yeah, I'm a Microsoft MVP recently. Probably not for very long, but that's okay. Right. Okay. So what are we going to do in this talk? Well, we're going to quickly have a look at what we're going to learn. Then we'll spend some time just getting familiar with the data set itself. I like presenting things in a very visual format. I learn visually. I like watching things. I think a lot of people do nowadays. That's why videos have become such a big part of training. But so yeah, I'm a very visual learner, and I enjoy making visual understanding type of demos and that. So I'm hoping that will help you guys. And then we'll go through the actual problems, and we'll deal with various problems and the solutions and how they work. You'll notice that this whole thing is kind of safari, South African wildlife themed. Yeah, I like to bring a little bit of South Africa into my talks as well, and but personal. And then, yeah, if there's any questions that we don't get to during the session, we'll have some time at the end to answer. And then I'll also share a link with you where you can go and read more about all the things we're talking about here. So that's where we are. Okay, so what are we going to do? Well, we're going to start by just understanding a little bit of theory. And I will very, very, very simply talk through a couple of theory things as we go. Then we're going to look at a visual example in PowerPoint, and I will sort of try and make it as comprehensive as possible, talking about which way that a relationship is flowing, how a filter is affecting it, etc., etc. And we try and show all of that with pictures. And then we'll go into Power BI and actually do exactly the same answer, the same solution, but we'll see it working in actual reality, not just on a slideshow where it's easy to manipulate. Okay, so that's basically the structure of the session and how I like to do it. Okay, so I said we're going to get familiar with our data set. The data set that we're talking about here is actually a data set of photographs. It's 16, or I'm actually not sure how many. I think it's more. I've added more photos. It's a whole bunch of photos that I've taken on various trips that I've made to Kruger and Tlhluwe and all these other national parks. And they are photographs that I've taken of wild animals. I have basically put them into a table, like a fact table called photo. It's quite a boring table. And then I have a couple of dimensions. So, you walk into a business and they're like, oh, our data is perfectly modeled, and you think everything is going to work. And then we're going to run into some problems. And that's exactly how we want this to be. So we start with what looks like a very good model and a very clean model, and we'll work into the various problems as we come along. Okay, so what does a row in our fact table look like? Well, each row represents a single photograph. In this case, this photograph of an inquisitive giraffe. So I even called it inquisitive giraffe. So each row has a whole bunch of attributes in it, or column values. Obviously, I have a key, which is really just a made-up number. I have a title. I have an animal key, which links to a dimension. I have a background color key, which links to another dimension, which we'll talk about later. It wasn't in the model you saw just now, but we'll get there. I have like some classifications, things like what kind of photo this is, where we took it, when I took it, what time I took it, and what the camera settings were. And then I have a link to the photograph with a URL, which all these photos are on my website. And that's just because I need the URL to actually view them in Power BI. So that would basically be one row of my data. Obviously, it could also represent another photograph like this, a tiny blue wax ball. And again, it would have all the same attributes, values. And we use that. So hopefully you can kind of visualize that as a pretty simple data set. We then have two dimensions. The one is a date dimension, which I'm not really going to explain. It's a pretty self-explanatory thing. But the other dimension we have is a animal dimension. And the animal dimension basically has a key, and then it has a bunch of classifications. It has the name of the animal, what class of animal it is, what order of animal, and what family it is. So just a couple of the scientific classifications of the specific animal. And we use that just now when we do some aggregations in that, and we'll see how all of that works. Cool. Again, another example of the same table and what it would look like for a kudu. Kudu with a hole in its ear. Okay, so we've had a look at our basic data model. Hopefully you can you see it. We only have one measure to start. To start our discussion, we're only going to talk about a single measure, and it's the simplest measure of all, which is how many photographs fit into a specific criteria. Okay, so in DAX, very, very simply, we have a measure called number of photos, and that is count the rows of the photo table. Okay, count rows photo. So that's all we've got. Our model is very, very simple. It's very, very clean, and it's meant to allow us to work through it quite quickly and to really understand what's going on. Okay, so now let's have a look at some of the problems that we might experience. Okay, the four things we're going to look at in this session. One is disconnected slices. And the second one is bidirectional filters. The third one is inactive relationships. And the last one is non-numeric measures. Okay, so all of these, none of these are particularly complicated. They're all sort of fairly standard things. And for me, they are all things that I've run into in business, in actual work that I've been doing at some point or another. And often the problem has been solved by the team who did the work originally. But when I go in as a consultant, I find out that it's very suboptimal. So I'm just going to let my dog out. So what we will do is we'll actually look at a variety of ways of solving these problems, and we'll talk through why some of them work better than others, and what the problems with some of the solutions that you may see out there in the wild, in your actual work. Okay, so the first one, let's talk about the first one. Early morning in the African bush, disconnected slices. Now, the reason I called this one early morning in the African bush is because the disconnected slices that we're going to talk about are actually times of the day. Okay, so the business problem here is that sometimes Power BI and DAX and tabular models can only handle a single column to single column relationship, right? So we know this. When you set up a relationship between two tables, all you can link is a single column to single column. Now, in SQL Server, you can obviously do different kind of joins. You don't have to join on one column equals another column. You can join on one column doesn't equal another, or is not equal to another column, or one column is greater than another column, or one column is greater than one column and less than another column. So you've got a lot of flexibility in SQL, which we don't have in a pure star schema model in Power BI. Okay, so we have to then do something to replicate or, to use that kind of functionality. So what's the problem? Not all tables can join using a single column. So how do we deal with multiple columns or range joins? Okay, an example question here that you might have is grouping by a range of numbers or dates, such as bucketing ages or salaries or anything like that, where you don't have a one-to-one relationship between a record in your fact table and a record in the dimension that you want to group by. Okay, so how do we solve this problem? Well, we'll look at a couple of different solutions, but the one that we're going to actually focus on as being the right solution, in inverted commas, the DAX solution, let's say, is to write a custom filter where we specify the stuff ourselves to create the relationship. And again, relationship is in quotes there. It's not a real relationship, but we use values from one table to filter values from another table, and we build a custom filter that way. Okay, so what DAX functions are we going to use to do this? Well, it's pretty simple. Calculate, treat as, and filter. In fact, in the example that I'm going to show you now, we're only going to use calculate and filter, but you can also do this with treat as. It's just an alternate way, but it's the same basic idea. So let's have a look at our question. Basically, I've got 4 photographs of lion that I'm looking at in my data set. Each one of them, as we saw on the fact table, has a time of day when I took it. Okay, so 4:32 in the afternoon, 17:51, 6:54 in the morning, and 6:37 in the morning. So I've got these 4 photos that were taken at various times of day. What I want to do, what I can do without doing any work, is I can group by hour, I can group by minute, but when I want to group by the time of day, where I have some range that says, you know, from midnight until 5 o'clock in the morning is the night, and then from 5 until 8 is the morning, etc., etc., that kind of grouping. I can't just do that with a single value. Well, I could, but if I did that, there would be a way, the way I would have to do that is I would have to create a table for every single possible value and create a one-to-many relationship. So I could have a table with, what is it, one record per minute of the day, and I could have a one-to-many relationship that says this is, you know, this time of the day becomes this category or classification or whatever we call it. Okay, and that would work, and that would be fine. But then what happens when my customer comes to me and says, actually, you know, we don't want it down to a minute level anymore. We now want it down to a second level. Now our table gets 60 times bigger. And then they say, oh, no, actually, we want it down to a millisecond level. And now it's 1,000 times bigger. And you've got this ridiculously large table just to bring back one single value into our report. It's a very inefficient way of solving this problem. Okay, so the other thing we could do, of course, is we could create a custom column. So we could move the problem onto the fact table itself, could create a custom column, and all the Excel people, this is exactly how they would do it. Write equals switch, open brackets, true, and then, you know, work out what time of day it's supposed to be and just make it into a column. But as soon as your fact table gets really, really large, then that adds space and computation, and it adds a lot of unnecessary overhead to our model. So it also doesn't have a great scalability as a solution. Okay, and that's kind of what this bit in the bright red says. Both of these solutions work in a small model, but are likely to introduce performance problems with the big one. So how do we solve the problem then? And all the things we're going to talk about today, the nice part about solving this problem is that you generally will only, you'll only need the value that you're going to calculate or create for one type of calculation. You're not going to reuse it in thousands of places. So you're going to write a measure, and it'll only get evaluated, and that work will only be done by the model if that measure actually appears somewhere on the report at runtime. Okay, so you're not going to bloat your model with unnecessary data all the time. It's only going to incur that cost or that overhead when you're actually looking for this solution. So here is the solution in full. It's basically to calculate, open brackets, the number of photos, which is a measure we have already defined. And then we put in a filter. We're filtering what table? Are we filtering the photo table? And then we've got some filter criteria. Okay, that's quite complicated. So let's go through it sort of step by step. Okay, so the first thing we're going to do is we're going to do the inner part of our calculate. Okay, so we're going to filter our photo table where the photo time, which is the field in the gray, is greater than the max time of day start time, and it's less than or equal to the min time of day start time, right? Okay, so when we go to our first row in our time of day table, okay, so we're going to put this on a measure somewhere. Note, we don't actually specify this. We don't actually specify this table name anywhere in our formula. So the context of this table will actually be created by us putting the value on a report, in a graph or on a table or somewhere like that. Okay, that will generate the context. Okay, so if we do this, let's creating this table example. We're going to say, okay, night before sunrise. When I'm looking at that specific value in my dimension table, then I will populate. Then the next thing that'll happen is it'll run this min time of day start time and max time of day end time. Now, you may wonder, why is it a min and max? Why can't we just say time of day and end time of day and start time and end time? Sorry. Well, the reality is that these tables don't have a relationship, so you can't do a one-to-one mapping. You have to assume that it could bring back multiple values. And in fact, we will look at an example where that happens shortly. So the min and the max means you have to write an aggregation on this data to make it work. Okay. So basically, it's gonna say, if we're looking in our table that says night before sunrise, it'll filter down to all those rows. Now we know there's only one row, so it'll bring back the min time of day start time, which is midnight. It'll bring back the max time of day end time, which is 04:59. And then it will filter the photo table by all photos that fit into that range. So what will happen there is that we'll actually get no photos in that filter, right? Because none of them are less than or equal to 4:59 in the morning. The earliest one is 6:37, and that obviously is not before 4:59. Okay, so it'll filter, it'll bring back a 0, it'll do that count, and it'll bring back that result. And just like all evaluation contexts, it will evaluate for every data point. So then it'll move on to the next data point, and we'll start with the morning. And it'll do the same thing. It'll go, what is the min and max time for the morning? It's got that now, 5 to 8 in the morning. And when we do that, we end up with 2 rows. It then performs the count, and we end up with 2. So it cycles through our dimension table. And for each row in the dimension table, or for each unique value in the dimension table, it then performs this filter operation, brings back a count of brings back a filtered set of photographs. Then it performs a count over that, and we end up with these answers as we have here. Okay, so I'm just going to skip through that. We don't have to go through them all time after time like that. Okay, so from my opinion, that's a fairly easy way to start. But I'm hoping you're already going like, oh, I've seen this problem before and I didn't know how to solve it. It's really cool to know that it's actually quite easy to solve. We use a measure we've already defined and we just add in a filter. Okay, everyone happy? No questions. I don't see any hands, so I'm going to carry on. Cool. So then let's look at the next problem. And this is exactly what I was talking about a couple of minutes ago. When we look at this problem, we're going to run into the first issue with our previous solution. Okay, so that previous solution works perfectly as long as all the values in your table are unique, all the descriptions that you're looking at. But now we're going to look at a different problem, because now I want to say night is anything before 5 o'clock in the morning and anything after 7 o'clock at night. So we're going to have 2 rows. We need to add them up and bring back that total in our value. Okay. So what will happen if we start running that same formula through this? Well, if we start, the first thing we do, you'll notice that we had 5 rows here. Immediately when we move forward, we've only got 4 unique values because night is repeated. So what happens? The first thing that happens, it puts night on our table, and we end up with the min start time and the max end time. And now we're ending up with, it brings back all of the photographs, because all of the photographs were taken after midnight and before midnight, which is not surprising because there are no other values that they could have been taken in. Like, it's literally basically any time during the day, it'll always fit in there. So this is the problem that we had, where I said that because we don't actually have a direct relationship, we now worrying about a situation where we use a min and a max and aggregation on that table. And in this specific scenario, those values are non-continuous, so we're actually covering a gap that we shouldn't cover. Okay, so that is an incorrect value. That's not what we want. So we've got to find a different pattern. Okay, so let's find a pattern that works. And here we go, slightly more complicated, but not really. We just use an iterator function instead of a base function. So we're just going to look at an iterator function, and it's pretty simple. So in the last example, I pointed out that we don't actually use the dimension table at all in our formula. We're using only the filter we don't specify the table, although we use two values from it. But now we don't do that. Now we're going to iterate through every individual row in our dimension table, get an answer for it, and then we'll only return the formula. So it's a slightly more difficult, it's a slightly different formula. It's not really more difficult, slightly more different, and it works as follows. Basically, for any row that only has one value in our table or only one row in the data, it works exactly the same as what we saw before. So I'm quickly going to skip through those three, and we'll go through those, and we'll just assume they work the same. But I'll give you the example that was causing us the problem before. Okay, when we get to night, what happens is that we get to the value night on our report or on our table. Okay, and that is this leftmost column in my slideshow, night, and you can see that it's a doubly thick row. So that's one value on the report, but it represents two values in our underlying table. So because we're iterating, we start by looking at the first row that matches this value, in this case, the row called night with the early start time. Then we go through there. We then perform the filter. So we now filter down the photo table based on where the time of the photo is greater than the start time of this one row. See, we're not doing a min or max anymore. We're now saying, because we have a row context, because we're iterating, we create a row context in our iterator table or in our dimension table. Because we have a row context, we can use a singular value, a singleton scalar value from our table, in this case, the start time field, and we can use a scalar value for the end time. So we're only getting a single row's worth of values. Then we can perform this calculation. So now the first thing we do is we look for all photos taken between midnight and 5 a.m. We get 0, okay? But we're still within the same row of our output because it's another row that has the same value. So we go back and we do the same thing again, because now we're looking at a second row. We're going night, where the time is between 7 o'clock and midnight. It goes there. It does the same thing again. It happens to also bring back a blank data set of 0. And then it goes outside to the SumX, and it brings back the final result of 0 because it sums up those two underlying rows, brings them back. So you won't see on your report, you won't see any of these middle columns, anything outside of the very leftmost column and the very rightmost column. That's all you would see. Is you would see time of day and the what we call it's SumX in this table, but the formula or the measure that we've done. So that would be how a slightly more complicated thing works. And this is nice because you can make it even more difficult or more complicated where you do, I must have hidden it. I think I hid this because the last time I did it, I had a shorter time period. But basically, you can also have the situation, and I'll show you in Power BI because we're going to go in there now, where you have different times specified for different seasons. So now you have to say, hey, I've got in summer, I say night ends at 5 o'clock, but in winter, I say that night ends at 6 o'clock because of the moon and the fact that the nights are longer and all of that. So we have shifting time periods, and now we're using a different thing to work out whether it's summer or winter, and we're making our formula much more complicated. So you actually have a few things you can do if you if you use that pattern. So let's go and see if we can find this. So we start here on our disconnected slicer dashboard. And you can see that basically tells us we've got all these simple measures here. Time of day, time of day, time of day. They're all working at the moment, which they shouldn't be. So I've clearly forgotten to update this thing. So let's quickly go in here. Sorry, and let's start from where we would normally start from. Apologies, I thought I had done this. So if we do time of day simple, yeah, okay. Time of day simple is the basic one that we started with. Okay, so this is that first formula that we looked at, just min time of day, max time of day, so greater than, less than, filter the table. Okay, so if we were to put that on any table, that one, well, on the first table that works because we know that on our first example we had 5 different rows. Okay, these values are not the same as the examples I showed you because I've got a lot more photos in my whole data set. But if we were to filter down to just lion, I think you would get exactly the same results. So if we just yeah, you see there we only get morning and evening. We don't get anything at night. Okay, but for our whole data set, this is right. What I am going to do now is I'm going to put the time of day simple measure on here, and you'll see that it breaks. That is definitely not. All 41 photos could not have been taken in the day, in the evening, in the morning, and in the night. That doesn't make any sense. So what's happening here is clearly that we've got that problem with the min and max, and it therefore does that. So we have to use that more complex formula. So we're going to take that one off now, and we're going to put number of photos on there. Where are we doing? Sorry, number of photos. So I should put it on the right place. There we go. Oh, I've done the wrong one. Sorry. Getting confused. So once we do that, our measure now works correctly. Okay. So you can see that the 2 photos that make up night, which are split up over there, now get consolidated into a single row called night over here. Okay. And then just quickly, we'll touch on that example that I spoke about earlier, which is that if we do the time of day, if we do the season one, you can make this more complicated by adding in additional fields. In this case, I've added in a related field to work out what the season is based on the date of the photograph. And then I'm joining it and saying it must match my season time of day because that table's a lot more complicated. If you look at season time of day, you'll see that we say in spring, the times are defined, then in summer the times are defined, in fall and in winter the times, and the times can be different for each season, and it'll still calculate and bring us back a different example. So you can see that some of the photos move from, well, 2 of the photos move out of day, and one moves into evening and one moves into morning. So obviously they're winter photographs that have moved, they're winter photographs that have moved into those other categories. Okay, so if anyone wants, we can go through that one in a little bit more detail just now. I do have a slideshow that shows it, but I take it out, otherwise it gets a little bit repetitive. But yeah, okay, cool. I'm going to move on. Has anyone got any questions, or can we go on to the next type of problem? Good. Okay, cool. Sounds good. Thank you. Where were we? PowerPoint slideshow. Okay. So then we can look at bidirectional filters. Now, I am assuming that most of you will have seen this in one way or another, but I'm just going to show you very briefly how to use bidirectional filters in a calculate function so that you don't have to put them in your model. But let's talk through the problem first. You can see that in a well-formed star schema, all our directions, like all the beaks of the white-fronted bee eaters, face in the same direction. They only go in one direction. So what is the well, that is the problem statement. In a well-designed Power BI model, we should strive for single directional relationships. But what if there is a business question that actually needs us to use one that goes in the opposite direction? Okay, so usually this happens when you need to count or get a distinct count or something else from from a dimensional table that is which has its own classifications in it. Okay, so you saw in our dimensional table we had the animal name, which is what we actually link on, and then we have things like the class and the family and the order. Okay, now those things are not unique in that table. So the one-to-many relationship is going to cause us some interesting problems there. Okay, so the simple way we could solve this problem is we could just set the relationship to be bidirectional in the model. But we know that this can affect performance, so we don't do that. We write our own custom measure again. And what are we going to use in this specific example? We're going to use calculate, and we're going to use cross filter. So this is a very simple one. I'm hoping that you'll all be like, yeah, I know how to do this, but we're going to talk through it and we're going to show you logically and visually what happens when you don't do it. So here we go. We have 4 photographs of blue birds. Okay. These are, I like birds. I really like birds. My dad and I spend a lot of time looking at birds, and it's part of our sort of bonding time. So that makes it special for me. And I enjoy spending time with that. So these 4 birds are all obviously quite pretty birds, and I chose them because they're not all brown and white and very difficult to tell apart. It's very simple to see that these are very different types of birds. And as you can see, that what we have here is we have 2 rollers, which are the top 2 photographs, and then we have a kingfisher, and then we have a waxbill. So these 4 birds only belong to 3 different families. And that's the question that we want to solve with this next little problem, is if given a selection of photographs, how many different families are represented by those photographs? Okay, so if I were to take all the photos that I took at night, or all the photos I took during the day, or all the photos that I took with a specific exposure, or all the photos that I took at a specific park, any of those things, how many different families of animals are represented? Now, I don't know if you can already see the problem, but hopefully it'll become quite clear quite quickly, is that the filters that we've applied, like I was talking about where I took them or what type of photograph or what time of day or whatever, they're applied on our photo table. And then we need to count something from the animal table, okay? Now, if we just needed to count how many distinct animals there were, it would be easy. We would just count how many distinct animal keys there were on our photo table, and that's fine. That would give us our solution. But we don't here. I need to go to the animal table. I need to pass the filter context from the fact table to my dimension table, and then count how many unique rows are in the dimension table. So why is that going to cause a problem? Well, if we, what am I trying to show here? If we go from animal to, if we go from the animal table to the photo table, it's easy, but but what problem are we going to have when we go in the opposite direction? Well, the measure we're going to use is very simple. Distinct count on that row, okay? So the animal family column, not row. We're going to do a distinct count, and then we're going to just work out what the answer is, okay? But when I look at all my birds, I've got 17 photos of birds, and I only have 15, families, okay? So when I then say, okay, well, then if I only look at the blue birds, okay, we're going to filter down on 4 records. The problem is that I've got these 4 records on the left-hand side in my fact table, but the direction, the filter doesn't flow from that table to my animal table. It flows the other way around. So even though there are only 4 records here, it's telling me I still have 15 families of birds, okay? Sorry. So that is the problem that we're trying to deal with here. So what we have to do is we actually have to tell the measure that it has to look in the opposite direction and bring us back the correct answer. Okay. So what are the potential solutions? Well, we've already talked about this. You can make the relationship bidirectional, but bidirectional relationships can negatively affect performance of a model and can also use to models that create ambiguity and are discouraged. So everything you read about Power BI will tell you, or most of what you read will tell you, avoid bidirectional relationships between many-to-one tables. Rather, be very sure about when you're using a bidirectional relationship and do it with the DAX. Okay. So what is the other thing we could do? Very similar to the last problem is you can actually use lookup value to add the family as an additional column, and you can add the fact table and make sure that, and then do the distinct count. But that's also not good for performance, and especially once you get your model very big again, adding additional columns is, especially columns that come from other tables which you can get from another by doing different things, is very, very wasteful, and it's going to cause issues. So we don't want to do that. So how are we going to write a DAX function a DAX measure that solves this problem? Okay, well, it's actually really, really simple. Instead of having our unique families, our number of unique families measure just be the second line here, distinct count of animal family, we're going to use we're going to wrap it in a calculate, which tells it basically we may change the context. And how are we going to change the context? Well, we're going to use the cross filter function in DAX to link the animal key in the animal table to the animal key in the photo table. And that final keyword, both, that basically makes that we are now using, we're basically saying, treat this relationship as if it worked in both directions. Okay, that's essentially what this cross filter does. So what we do is, just for the purposes of this measure, we now introduce a bidirectional relationship. So we don't build it in the model, we're just adding it in the measure. So only when this specific measure is applied will it use that bidirectional relationship. But because we do that, what it does is it now creates a bidirectional relationship between our fact table and our animal table. So when we filter our bluebirds, however we got there, we get to the 4 bluebirds. It now filters to those 4 rows, and then it performs a distinct count on the table, which only brings us back 3 records, and that's what we're looking for in our answer. Okay, so this is, as I say, this is quite a self-explanatory, quite a simple thing, but it can get a little bit more complicated. So what if we have a bridging table? Okay, so in this case, now we have our animal table, which points to the fact table like before, but it also points to a table called animal color. Why does it point to a table called animal color? Well, you can see in all of these photographs that an animal may have more than one color. Okay, so in this case, some of these birds have actually 7 or 8 colors, I think. I think the lilac-breasted roller has 8 different colors in it. Okay, and then this one has 3 and 4, and this one has the black and the red and the blue and the white. So we've got a whole bunch of different colors here. So we can't have a one-to-one relationship here, clearly. And we can't have we have to have a one-to-many relationship between animal and color, which means we have to have a bridging table. Oh, sorry, we have to have a many-to-many relationship between animal and color. So many different animals can be blue, and one animal can be many different colors. So we've got a many-to-many relationship here. Now in a star schema, how do we solve a many-to-many relationship? We create a one-to-many and a one-to-many with a bridging table. So now, if I'm looking at the bluebirds, which is a filter on my photo table all the way down at the fact level, and I need to work out some stuff about the colors, we're going to have to do some very interesting things to get there. Okay, so let's look at this example. So if I look at the blue wax ball, for instance, okay, so number of animals. So we've created a new measure. Sorry, we've created a new measure here called the number of animals, and that basically shows how many records in the animal table match a specific criteria, and we're gonna use that. So to get there, if we want to say how many animals are blue, we have to be able to go through from our color table to our animal table. But if we remember our relationships, there's no relationship that flows from color to animal. There's two different relationships, and we're going to have to manipulate them. Okay, so the first thing we're going to do is what we're going to try and do in this specific problem is we're going to say for each of these colors, how many of the birds represent that many colors, okay? And it's going to respect the filter context that we've got. So it's only going to talk to the five pictures, 4 different animals that we've got showing on the screen. So there's a couple of things at play here, okay? So the first thing we have to do is we have to get from color all the way down to the animal photograph. So what happens is we start with the color, obviously, because that's what the context is that we put on our report. And we go from red, and it filters down to that one record, the woodland kingfisher. So that's pretty cool. We think it's going to work fine. But as soon as it tries to filter down to the animal table, it encounters the problem we had before, is that the relationship is going in the wrong direction. Okay. So in this case, we just have to add in a single one-to-many a bidirectional relationship from the animal color down to the animal table. Okay, so what we do there is we just add in that single we add in that single relationship, which will make us then go from red through red. This is the bidirectional relationship we've just created between animal and animal color, okay, which then filters down to that table, filters down here, and works perfectly, okay? So the only thing that we're trying to show here is that the rest of the chain is still respected. So if you create a bidirectional relationship in the middle of a chain, all other relationships can still flow all the way through. So in this case, we can go from color all the way down to our fact table just by creating a single bidirectional relationship. But what if we want to go in the opposite direction? What if I want to start at my fact table and then work all the way up to the colors? So I want to now say in each of these photographs, how many colors do I see? Okay, so now I have to do a whole bunch of different stuff. Now I've got a bit more complicated stuff going on here. So now I have to introduce too many bidirectional relationships, okay? Because what we're trying to do is we're trying to go from the left side of the screen to the right-hand side of the screen, and we want to count. And you can see that if you follow the arrows, there are 2 arrows that are pointing in the wrong direction for us to do this. So we can't go from the left-hand side of the screen to the right-hand side of the screen with just a single bidirectional relationship. We actually have to create 2. Okay, that's because if we start at this photograph, the woodland kingfisher, and we add in a cross filter, or to get all the way to the final photograph, we have to go through all of these and we have to add in 2 bidirectional relationships, which means we go to woodland kingfisher. We then go to those 4 colors, which filters down to those 4 rows of the color table and brings us back a result set of 4. Okay. I'm hoping that makes sense. It's a little bit like you're getting, it's starting to get a little bit tricky, but really what this is just showing is that you can use multiple cross filters in the same DAX measure. So we can actually make multiple relationships treated as bidirectional in the single measure, within a single measure without having to do multiple different steps. You just put in different filter contexts. Okay, so let's quickly pop into Power BI and see that actually working. So if we go into our bidirectional relationships table here, again, if we look at this, there are a couple of different measures here. This is the last measure that I was talking about, the number of photos per colors per photo. And you'll see that if I click on a specific photo, it'll actually not listen to me at all because it clearly set up the interactions wrong. edit interactions. So if we go from this table there, let's filter, make it a filter, make it a filter. Okay, and let's do that. So if I filter down to how many photos I get on a zebra, I get 2 photos. Surprisingly, it's black and white. Okay, on a zebra photograph. So that measure works quite nicely. I don't know if you want me to go backwards and show you how it doesn't work until you add in the relationships. We may as well. Let's do that. So let's start here and go to color metrics, number of colors per photograph. So if we take out these 2 cross filters, okay, that's not gonna work. I'm gonna just have to put in, let's just do that. Okay, so that just calculate number of photos now. So that becomes our new measure. Okay, if we do that, you're gonna see that every photograph comes back with all the colors of my table, or all the different colors in my color table. Okay, if I add in just a single cross filter back, if I add just a single cross filter back, nothing changes, because we still can't get from number of color from the animal table all the way up to the colors table. But as soon as I add back the second one, now we have both of them. Okay, so basically, as you click on any animal, you'll actually be able to see how many colors that specific animal has on them. If I were to select multiple photos here of the same animal, if I can find well, there's a hyena and there's a hyena. Can I select 2? I can't select 2 photos like that. But let's say if we go to animals and we choose all the hyena photos. Why am I? It's spotted hyenas. That's why. So there we've got 3 photos of spotted hyenas, but we only come back with 1 animal. So you can see that we've got all of these relationships that are now doing what we expect them to do. So I'm filtering on the photos, and it's doing all those things. So it's bringing back the 3 different colors. The hyena has black, brown, and tan on it. Okay, cool. Any questions on that one? Did I confuse anyone? Or you all just want to go and drink now? That time of day? No? Okay, cool. Let's go on. The other 2, the last 2 steps we're going to talk about are pretty simple. You may actually have seen them before in your lives, so maybe we don't have to spend a lot of time on them, but let's do it anyway and go through them. Okay. So inactive relationships and role-playing dimensions. What is the business problem we're solving here? A single dimension could have multiple relationships to a fact table, and we might want to slice using more than one relationship in a single visual, but only one relationship can be active at any given time. So usually, and for the example that people usually talk about here is ship date, order date, completion date, return date, all of these different things. You might have 10 different measures, all talking to a date table, and you now need to decide which one you're using for a specific measure. Okay. So an example business question here. Well, I've just talked about the dates, but also maybe this one in hospital is how many people were admitted today versus discharged today. You've got 1 axis, but 2 relationships to the fact table. Okay, so how do we solve this problem? Well, again, basically like the other 2 problems we've looked at, we have to write a measure which is explicitly forced to use the inactive relationship to give us the answer that we're looking for. Okay, so again, pretty simple. We're going to use calculate and use relationship to solve this problem. Okay, so back to our colors. So when you go to the bush, you have the colors of the photographs or the animals in the photographs, but you also have the backgrounds of the photographs. And sometimes you might want to count photographs based on what color their backgrounds is, or the primary background color that you might have in this case. So we may be able to say that some of our photographs are taken against the skies, some of them are taken against trees or leaves or very green grass in summer. Some of them might be taken against brown grass in winter, and then dark colors in water or night or whatever it is. So here's a place where we may have an inactive relationship between the color table and the photo table, because we're going to say basically there's only one background color. And we've got this long convoluted relationship between color and photograph based on the ones we talked about before. But we can only have one active one. Even though there's not a clear path between color and photo, you wouldn't be able to have both of those relationships active normally. Otherwise, you would end up with a circular dependency or whatever they call it. So we now have a situation where we have to use the inactive color, and all we want to do is we want to count how many photographs were taken against the specific background color. Okay, we're going to use that relationship. And it's really cool because it's so simple to solve. All we have to do is tell our DAX measure, just use this relationship. And we specify the relationship by specifying the endpoints or the columns of the two edges of the relationship. So color to color key and color key to animal background color key. Okay, so we've got that relationship, and we're just going to tell our DAX measure that's the one we want to use. Okay, which basically then firms it up. So that really is an easy one, and I can actually show you this one quite simply in the Power BI report again. If we were to go here, number of photos by background color, if we change the measure so that we don't use that relationship and we save it, what are we expecting to see? Well, because there's no active relationship between the colors, and in this case, remember that our colors don't have a direct relationship to animals, to the photos at all. We don't see anything here. But as soon as we add that number back and we add them in, then suddenly we get our relationship being respected. Okay, so this again, pretty simple example, but it does show how that by using a custom DAX measure, we get the answers we're looking for in the specific question. All right. Okay. And then the last sort of business problem we're going to talk about, and this is one that I quite like, and I don't see a lot of people talking about it or using it or whatever, but I often add these on dashboards and reports because I think sometimes they give extra context. So sometimes you don't want to see a number. You want to see the thing that generated that number, but only that one thing. And the example that always comes to mind is, for me, if you're talking about, let's say we're going to a sports competition and you want to talk about who's scored the most goals, okay? You're not going to, the thing you want on the measure is not the number of goals that the top goal scorer has scored. You want to see who it is. Who is that person who has scored all those goals? And you might want to show that in a photograph, or you might want to show it in a text like their name or something like that. Or you might want to show it their name and the number of goals they've scored. But all of those things are not so easy to achieve out of the box, because a lot of the things we think about, max, min, are all numeric measures. They all come back with numbers. So how can we deal with some of those kinds of problems? Okay, so we traditionally think of measures as having a numeric data chart, so we can put them on graphs and charts. But there are ways to use other types of measures that can also provide business value. Okay, so again, show the name of the top performer within a data set, taking all filters into account, show the image, show all those kinds of things. Okay, so how do we solve the problem? A DAX measure doesn't have to be a numeric measure. A DAX measure can have any DAX data type. So you just have to know how to create measures that return different data types and how and when you use them, and then you can solve this problem. Okay, so some of the ones we're going to look at here are calculate, top n, concatenate x. We're also going to look at min and max in sort of things that we don't think of as numeric but are treated as numeric, and examples like that. Okay, so this one is quite cool because we don't have to actually go through any theory. All we're going to do is look at these answers, and I quite dig this this page on my report, or this page on the report that I built, because it does some quite interesting things. So all of these these 4 measures that we're talking about up here. So first sighting, earliest sighting, latest sighting, and most frequent sighting. Those are all non-numeric measures. Okay, these are all different things that I've created and different ones that we're going to look at. And you'll see that if I choose to apply filters, they're all respected. My most frequent, or my first sighting from a filter of a bird is not a lion, and my my first sighting of a dog is not a bird. So it's respecting all of these. It's respecting all of these filters that we're applying because of the way we've written the measures. So let's have a look at a couple of these, okay? This one is the easiest. This earliest and latest is the easiest of these non-numeric measures in this example. I just got to find them. Bill, this one. No, not that one, that one. So earliest sighting, and you can see literally a single line, min, photo time, okay? So in DAX, or in the tabular model, just like in Excel, dates and times are actually stored as numeric values. There are specific types of numeric values. You don't really have to know what goes on behind the hood, but you can perform a min or max function on both dates and times, and you can bring them back like this. But that is still not a numeric measure. You could not put that, for instance, on a graph. You couldn't put a 453 on a graph as a value. You might be able to put it as a dimension, but you couldn't put it as a value on a graph. So these are the first examples of a non-numeric measure. Okay, the simplest ones. Then the next most simple one is this idea of the first sighting. Okay, the first sighting is basically what is the row with the earliest date or time. I can't remember actually what I'm calculating on. Top in photo, date, and time. So we're going to basically the first photo I took that matches the criteria that we're looking at here. Okay, so this is a pretty simple. Again, it's actually quite simple measure here. Our first sighting, we have this idea of concatenate x, and sorry, I'm just trying to work out. Okay, so what do we do here is we bring back a top n, which is basically the top 1 in this case, because I've specified 1 as the first parameter, but it basically takes a table and brings back the first however many rows, and we've specified 1 here. Okay, we then tell it that what we want to return. Sorry, let's just go back. In the top n, we have to tell it which table we're going to bring back the top rows from, and how are we going to sort the rows. So in this case, I'm sorting by date ascending and then time ascending, which means I'll bring back the first one always. Okay, and then once I've got that, so that's the whole table. That's a filtered subset of the table. Then what do I want you to bring back? Well, I want you to bring back this URL for me, because the URL will allow me to display the picture. And then the interesting thing is, what is the rest of the stuff for? Concatenate X. Well, in this specific case, it's actually not serving any purpose at all, because you can't take 2 photos at exactly the same time. But if you were to, you would need to be able to deal with that situation, because the top N is a misleading statement. You say to it, bring me back one row. And actually, it then brings back any row that has the that has the minimum value. So if you have any ties, it would in fact bring back 2 or 3 rows. And we're going to look at an example like that in the next one. You could, of course, make sure that we don't solve this problem in this measure because we want to have a photograph. We know that we have to only bring back one at a time. Because if I bring back a URL that has 2 different photographs in it, it's actually going to break. So, and maybe I can show you that quickly. Let me just do that. If I take out the time, I may be able to actually show you that I can break it. Yeah, there we go. I think I've done it. So it's brought back. You can't really see that image very well, but let me just see if I can change the font color quickly for you. Wait, size and style properties. Do we have image? I wonder where it would tell me where the image was if it doesn't bring it back. Okay, it doesn't. It does. I don't want to waste your time. But basically, there is a whole bunch of font here which says the image, blah 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 blah, and it's actually got 2 links. Could not be loaded, and that's because we're bringing back 2 rows because I took more than one photo on the same date. But if we were to put that back now, obviously, and we make it a unique image, it works again. So if you were to ever use this technique, I would suggest, just to make sure, add in something that you know is unique. So we could, in this case, go photo. The key, we know that the photograph key is there somewhere. What is it called? Photo key, that one. So we know that that's unique. So regardless of what happens, I can never get a duplicate as long as I've got the photo key column there as part of my order. And then to be technically correct, you should also specify in what order you're sorting it. So we're going to sort ascending. Okay. So what happens if we want this one where we do have multiples? Okay. And you may have seen it as I was flicking through the examples earlier. If I choose a bird, I get it. You see here in this measure, most frequent sighting, I get lilac-breasted roller and white-fronted bee-eater because I've seen 2 of each of those. Okay, so you can see that in the specific picture here. Okay, so just from looking at that, you can actually tell what it is that we're trying to represent with this measure. We're basically saying, of all our photographs, what animal have we taken photos of the most times? Okay, and if I take off this filter, you can see that I've taken 4 photos of lion. So lion by itself sits as the answer, but as soon as I choose birds, then I get this duplication. So how do we do that? Well, it's quite similar to the last measure, because even though the last one was a image, but it brings back text, and then we just display it as an image. But this one, we're going to actually bring back text. So we're going to do a couple of things here to make this easy to read. So the first one is we're going to basically say, our most popular animal is our same top N that we saw before. So it's the top 1 from our animal table based on number of photos descending. So we take the animal photo, bring back the answer. Now we know that in this specific scenario, it's going to bring back 2 rows. Okay. So then the next thing we do is we do a number of records count. So we basically just say, okay, how many rows came back in that first result? So V most popular, we count it, how many rows came back, and we get an answer of 2 here. And then we go into this return function, and we basically have a thing that says here, if V underscore number of records is greater than 3, then all we're going to bring back is we're going to say 3 animals, or 4 or 5 or 6 animals. So the number of records and animals. So we don't get a ridiculously long string of like 100 different types of animals because of the fact we've taken 1 photo of each of them. So we want to avoid that. So we put in a max value, and we basically say, so if we see more than 3, bring back just a list that says 3 different or 4 different or 5 different animals. If we see less than 3, then bring back a concatenated list from our most popular table of the animal name concatenated by unichart 10 and unichart 13, which is basically a line break, and sorted by the animal name ascending. So basically, if we take our 2 rows, as we did before, it will take the 2 rows. It'll say this is not greater than 3, so we need to go into the concatenate, put it in alphabetical order, lilac-breasted roller, add in a line break, next one, add in a line break, and there we go. I think, I'm just trying to remember how I did this last. There is a way that I can just show the other way that these photos work. Oh, I think it's if I go to a park location, if I go to Pilanesberg. There we go. So at the Pilanesberg, I only took 5 photographs. Each one of them was a different animal. So you can see I don't bring back the list of all the animal names. I just say there are 5 animals. Now we could bring back that list name if we wanted to. Let's go into our measure quickly and just show you what would happen. So if we change this to, if only do that if it's 23 or more, then you see that we actually get a list that says each of the different animal types in that concatenated list. But we also know that our text box could only actually handle 4, so we made it 3 to make sure that we shouldn't ever spill over. Cool. All right. So that's the end of my presentation, I believe. If you are interested, there are articles and more in-depth explanations of all the different functions that we've touched on today during this session. In this blog post of mine, it has a bunch of links in it. It has some explanations. It has some stuff that I've written and some stuff that other people have written. And yeah, you can go and see any of those things. I can copy and paste it into the chat if anyone's interested. And then yeah, any questions?
Thanks, James. I've looked at the